Hi, in this video, we will go through how to approach confidence interval under the Z procedure. A level C confidence interval, CI, for a parameter has two parts. 1. An interval calculated from the data, which has the form estimate plus or minus margin of error. 2. A confidence level of C, which gives the probability that the interval will capture the true parameter value in repeated samples. That is, the confidence level is the success rate for the method. When we use T procedure, we need to check the conditions. We use the T procedure if 1. The data is an SRS of size n. 2. The population normal distribution assumption can be relaxed. If n less than 15, the data need to appear symmetric, single peak, with no outliers. If n is less than 40 but greater than or equal to 15, the data need to have no outlier nor strong skewness. If n is greater than or equal to 40, then there is no restriction on the data shape. 3. Both mean, mu, and standard deviation, sigma, are unknown. Since we do not know the population standard deviation, sigma, we estimate the standard deviation of mu hat using data. The estimate is called standard error, which is equal to the sample standard deviation divided by root n, the sample size. Now, we modify the interval as x bar plus or minus t star times s divided by the square root of n equals the interval from x bar minus t star times s divided by the square root of n to x bar plus z star times s divided by the square root of n, where t star is the critical value such that the density curve of t distribution with degree of freedom, n1, has an area c between negative t star and t star. During exam, you may find this question. A small tech startup is interested in the average daily screen time on gaming of their target demographic. They randomly select 12 individuals from their user base and track their screen time for several days. In their sample, the mean daily screen time for these individuals is 5 hours with a standard deviation of 1 hour. Construct a 90% confidence interval for the mean daily screen time of their entire user base. Assume that screen time follows a roughly normal distribution. Step 0. Identify the question. We first verify whether the question satisfies the T procedure. 1. The data is an SRS of size n equals 12. 2. The population follows a roughly normal distribution, which is important as n is less than 15. 3. We do not know mean mu nor the population standard deviation sigma. Then, we can calculate the 90% confidence interval under the T procedure. We need to emphasize here again that the standard deviation here refers to the standard deviation of the sample, not the population. Step 1. Copy the formula for confidence interval under T procedure. You can find the T interval formula in the formula sheet as x bar plus or minus t star times sample standard deviation, s, divided by the square root of n. Step 2. Identify numbers. You can identify the symbols in the T interval formula. X bar is 5 hours, which is the sample mean daily screen time. The sample standard deviation is 1 hour. N is 12, the number of individuals sampled. The degree of freedom is 11, which is n minus 1. T star is the critical value that can be found in Table C from the formula sheet, and a minimized version is provided here. Different C levels will have different critical values. The question requires a 90% confidence interval, which means that the confidence level is 90%. As calculated, the degree of freedom is 11. We check the critical value under the column, confidence level, equal to 90%, and the row, the degree of freedom, equal to 11. We have the T star to be 1.796. Step 3. Substitute numbers. We, then, substitute everything into the formula. We have 5 plus or minus 1.796 times 1 divided by the square root of 12, which equals the interval from 5 minus 1.796 divided by the square root of 12 to 5 plus 1.796 divided by the square root of 12. Now, you can put everything into the calculator and calculate. We have the confidence interval to be 5 plus or minus 0.52 hours, or between 4.48 hours and 5.52 hours. We conclude the answer as we are 95% confident that the unknown, but fixed, mean daily screen time, mu, lies between 4.36 hours and 5.64 hours. Quote, "Wow, they spend so much time on gaming. How can they pass our STI exam?" Now, you can use TI-84 to check your results. First, press Stat, then Tests, and choose 8, T interval. Second, choose the tab Stats and enter, x bar is 5, sample standard deviation Sx is 1 and sample size n is 12 and C level equals 0.9. Lastly, move the cursor to calculate and press enter. You can see that the interval is 4.48 hours, 5.52 hours, which is the same as ours. Since we are working on confidence intervals, we need to emphasize the following concepts. It is the confidence interval to be random, not the parameter mu. That means if we repeat the study and calculate the 95% CI again, 95% of them will cover the fixed but unknown mu. The graph on the left shows the confidence intervals from 20 samples, assuming the true mean mu is 5 hours. You can see the confidence intervals are different from sample to sample, but the mean mu is unchanged. Also, the widths of the t-confidence intervals are not the same, so we do not have a simple formula for the sample size n for a fixed margin of error. On average, there will be 1 out of 20 cis that does not cover the fixed but unknown mu, which is indicated by the red interval in the graph. Let's make students hate statistics less.